Hello everyone. In this video, we will see that how to evaluate the values of specific heats of ideal gases. Gases have two types of specific heats. First is called specific heat at constant volume, denoted by CV. And the second one is called specific heat at constant pressure. This is denoted by Cp. The ratio of these two specific heats is defined as equal to gamma. The value of gamma depends upon the number of degrees of freedoms in the gas molecule, and it's well defined in the terms of equivalent number of degrees of freedoms for a given gas. So we know one relation between these two variables of Cp and Cv. In order to evaluate the values of Cp and Cv, we require another equation. So we take the definition of enthalpy as the second relationship. The definition is given as enthalpy being equal to internal energy plus P into V. Here P is the pressure of the gas and V is the specific volume measured in meter cube per kg. The enthalpy of an ideal gas is given as Cp into T, while the internal energy is given as Cv into T, where T is the temperature of the gas. Putting these values of enthalpy and internal energy in the relationship of enthalpy given on the top, we get Cpt equal to Cvt plus Pv. Now we replace the value of Pv using perfect gas equation. Pv is equal to RT. With this, our relationship between Cp and Cv becomes Cpt equal to Cvt plus RT. The temperature cancels out from both the sides and we get a relationship between Cp and Cv as Cp minus Cv is equal to R. We can take Cv common from the left hand side of this relationship and use the definition of ratio of specific heats as Cp by Cv is equal to gamma. With this, we get the value of Cv as being equal to R by gamma minus 1, and by definition of ratio of specific heats, Cp comes equal to gamma R by gamma minus 1. The ratio of specific heats of a gas, that is gamma, depends on the number of degrees of freedom of a gas molecule. For a monoatomic gas, gamma comes equal to 1.67. For a diatomic gas, it's equal to 1.4. For a triatomic gas, it becomes 1.33. And the value of gas constant of a gas depends on the molecular weight of the gas. So that's all for today's video. Keep watching for more easy derivations in thermodynamics and compressible flows.